This is your second video about polygons that are quadrilaterals, and specifically we are going to look into parallelograms. So let's review. Polygons must meet the following conditions. They are formed by 3 or more segments or sides, and none of them are collinear. Hope you remember what that means. And each side intersects exactly 2 sides at each endpoint. Intersect, I-N-T-E-R-S-E-C-T-S, intersects. Quadrilaterals must meet the following conditions. They're formed by 3 or more segments or sides, and none of them are collinear. Each side intersects exactly 2 sides at each endpoint, and there are exactly 4 sides. A parallelogram is a quadrilateral with both sides, or 2 of opposite sides, that are parallel. So what markings do we need to draw in order to be sure that a figure is a parallelogram? This means that a parallelogram must meet the same conditions as a polygon and the same conditions of a quadrilateral, plus 1 more. So formed by 3 segments or more, plus each side intersects exactly 2 sides, formed by 3 segments or more, 2 sides, and a quadrilateral which has 4 sides, plus 1 more. Both pairs of sides are parallel. Three, 2, 4. Okay, let's continue. Now draw a polygon that is not a quadrilateral, and then explain why you drew it the way that you did. A polygon that is not a quadrilateral. So I'm going to experiment, and I think I'll draw something that looks like this. So I have endpoints here and here and here and here, but it does not have 4 sides. It has more than 4 sides. I'll just clean that up here. Now let's try something else. Let's draw a quadrilateral that is not a parallelogram, and then explain why, or what you're thinking of. So I'm going to give you something to maybe refer to. It has 4 sides, but none of the sides are parallel, so it couldn't possibly be a parallelogram. So if a figure is a parallelogram, we can make a few conclusions about its sides and its angles. The opposite sides of a parallelogram are congruent. And we can see this as it's been marked. The tick marks, we have the single tick marks here and here. We have the double tick marks here and here. That means that the opposite sides are congruent. Now, why would this make sense? Well, let me suggest this. Let's say you have lines that are parallel. We're not quite sure how long they are. But I have another set of lines that are parallel. And when they cross over each other, if I was going to erase where the lines stick out, you can see that it turns out that the opposite sides are in fact the same length, and we could measure that to prove it. Now, the opposite angles of a parallelogram are also congruent. So this has been marked. We have the double half circles on the Q and the S, and we have a single angle that's been marked, a single line for angle R and angle P. That means that they're congruent. But why do you think that really is the case? Well, I have a suggestion. We know that we could have a shape where the angles that are formed are 90 degrees. So with a four-sided shape, if we had 90 degrees and 90 degrees, then this would be 90 and this would be 90. That means that this angle is congruent to this angle because they're both 90 degrees. Now, if I change this and I made a quadrilateral that had slightly different angles, it means that this angle here is going to be less than 90, but this angle here will be that much more because together they would have added up to 180. And so this, let me make that red. This angle is now congruent to the opposite angle. The consecutive angles of a parallelogram are supplementary, which means that they add up to 180 degrees. So that's something that we just learn, we can practice with. It's part of the condition of a parallelogram. Why does this make sense? Because the interior angles of a quadrilateral are 360, and we find that one angle right after the other will add up to 180. One might be less than 90, and then the other one would be more than 90, but together they would make a sum of 180. Diagonals of a parallelogram, they bisect each other, which means that the diagonals meet at the midpoint. So we've got this labeled M for midpoint. What does midpoint mean? Makes sense because, again, if you have lines that are parallel and they are congruent, then the distance across as a diagonal will also be the same. Make some tick marks here. If it's the same distance, because they're parallel, then the distance across will also be the same.